Alright folks, for this video we are going to be doing the cam programming of the Vise base. So this is the same Vise that we designed in the previous videos. We have our 6 separate parts, and today we'll be going over the Vise base. This will be how to set up the cam programming. So previously we've done computer assisted design, CAD. Now we'll be doing computer assisted machining, or aided. I don't know. CAD. We're doing cam now. So we're going to be doing the cam work for the Vise base. So in order to get just the base isolated, we are going to turn off the visuals for the other bodies. That way when we start programming our raw stock, it doesn't take that into account as well. So now we've just isolated the base by going to bodies in the drop down and just deselecting all of those. So now to get from the CAD to the CAM section, we're going to go up to design, click the drop down, go down to manufacture. Once you're in the manufacture tab, you'll have something that looks similar to this. Up top we'll have milling, turning, additive, inspection, fabrication. So for this is going to be a mill job, so we're going to keep it on milling. And we will start by setting up a job. So to set up a job, which is where we'll specify our G54 offset for 000, we are going to go and click this button right here, Setup. Now once we click that, it is going to automatically give us a stock size and shape. So a lot of times it just defaults right here to stock shape of relative. You can change the defaults by clicking mode. Over this mode you can click and set whatever default you like. I'm going to go to a fixed size box because I know I'm going to be buying stock that is 2 1/4 by 2 1/4 by several feet long. So here I'm going to overwrite 2 to 2.25 and Z height 2.25, and for overall I'm going to cut it 1/4 inch longer as well, so 6.25. That'll give us extra material on all sides to cut our block out of. Now, if we go to our tabs and look at how we're going to be setting this in the vise, we know that our vise is aligned on our mill along the y-axis, and we want to be grabbing it by these flat sides here because that's going to give us the most secure grab in the vise, which means we need to realign our XYZ coordinate system. It automatically aligns based on the XYZ coordinate of the drafting you did in the design phase. And so to change that, in this first tab in setup, orientation, it's going to say model orientation. We're going to select Z and X axes. So once we select that, it wants me to select a Z axis. So this face will be our up Z axis, and X axis. So I want this to be my X axis. So now I'm aligned. Obviously this box shifted with it because I had my stocks set with XYZ, so I need to adjust that now to 2.25, and for our X width now is 6.25. So now we have our coordinate system going in the correct direction, and we also have our stock size in the correct direction. In this setup tab, we also have other options for placing our origin. Right now it is sitting in the center of our stock. So to set up, once I have this in the vise, grabbed in the vise, I'm going to touch this side with edge finders to get a center point on the stock. 0, touch, find center, and Z is just touching off on top of the stock. So if I want something different, like a corner or an edge or a side, in this drop down right here, I can select model origins, selected points, so I can actually set a point out in any XYZ plane I want to in the drafting section and then select that point later. Stock box point, or model box point. So if I select model box, this is showing the outline of the model now, and I can select along the sides, the center of any of these faces. But I am using just raw stock, so I'm going to do with a stock box point and select center. So I'm selecting center so that way if I undercut or overcut some of my lengths, the machine will compensate for some of that. So I'm top center. That's going to be the easiest one to start off with when you're cutting raw stock. If you already have some machine surfaces, then you'll want to use a model box point. We'll show that later because we're going to do multiple setups on this part to get it all cut, because each time we do a different kind of setup where we're taking the part out of the vise and putting it back in, we're going to have to redefine our XYZ plane. If you're curious on which way Y goes, which way Z goes, and which way X goes, it is standardized. So I'm just going to hit OK to select that. Now I have a setup. So if you're curious, here is a 3D model of the machine we're going to be using. This was automatically imported into Fusion itself. So I didn't draft this. Fusion already had it in its setup. But it shows our table and our XYZ coordinates. So the green line is Y, blue line is Z, red line is X. So right now we have X going back, or Y going back, X going to the right, Z going up, and that will match this orientation of our block. X going back, Z up, or X right, Y back, Z up. So our block is going to sit roughly that shape into the machine here. All right. So once we have this into our setup, we can now start programming our tool paths. So the tool paths can be found in the drop downs here, also along the bar. This is like I was talking about previously in the design feature, where you can pin your most used functions to the top of the toolbar, and you can use the drop down to get whatever else you tend to use most. So if yours looks a little different from mine, that's because I have pinned and unpinned things that you might not have set up and pinned. So the first thing we're going to do is a 3D roughing pass. So adaptive clearing is one of the most efficient ways in this program just to remove a lot of material. It's rough. It tends to not do curves very well because it extrapolates points along the curve to make the machining more rapid, which is good for what we're doing when we are just roughing material away. So I'm going to select adaptive clearing, and I'm going to get this drop-down menu right here. So first of all, I need to set up my tool. So I'm going to hit select. In here is the tool drop-down menu. So this first drop-down right here shows the setup I have. If I have tools already loaded up, they'll be here. Local is what I have saved to my computer. So in the local drive, this is everything that I have set up or done in my computer. I have an entire Haas tooling catalog downloaded, and I can show you how to do that in a second. And I also have the library, which I have imported manually, or not imported, but manually put in tools for. I'm going to show you how to do this where we manually set up a tool, just so you can get a hang on that, and then I will show you how to import entire tool libraries. So if I'm setting up a brand new tool and it's not in my tool library or the Haas tooling library or one of the other vendors, I can go to this plus sign right here, which is new tool, click on that, and it's going to give me options: milling, hole making, turning, cutting, probe, holders, and deposition. So I am going to be going with a flat end mill to do most of this work. So flat end mill is right here. And here I can put in a description, vendor, product information, all that. Since I am not going to really be using this tool too much, I don't really need to put in all that information. So this is the most important tab right here, one of the most important, the cutter information. So obviously I've already decided I'm using a flat end mill. The units will be inches. This is a clockwise spindle rotation, so a right-handed bit. That's pretty much all bits are right-handed, so you don't have to worry about that too much. So now, number of flutes. So this end mill will be using 4 flutes. So I'm going to leave it at 4. It will be a carbide end mill. The diameter I'm going to be using is 1/2 inch, so 0.5. And it's the FX shows that this actually has a equation linked to something else inside of the program. So it's going to auto update the diameter with the shaft diameter. You can change that manually if it is something different. For the tool I have in front of me right now, the shaft and the cutting diameter are the same. If you're curious about what section they are asking about, it gives you this little highlighted information on what they're asking for. So shank diameter, cutting edge diameter, overall length. So the tool I have here, I'm going to measure it. Overall length is 3.5. Length below holder. So length below holder, this can vary. Obviously, it depends on how you set up your tools. Usually, when I look at an end mill, like a coated carbide end mill like I have with me right now, I can see where the coating ends. And it's going to end just a little bit up the flutes, or past where the cutting flutes are. And that's usually as far as I stick my tool in, and I use that as a good visual representation. So for this one, it is 1.25. So the shoulder length is usually only necessary if you have a difference between your shaft diameter and the diameter of your cutting flute. For this one, it's the same all the way through. So usually, again, instead of just picking a random number, I choose where the edge of the flute ends. Not the actual edge of the cutter, but the edge of the grind for the flute. So for this one, I'm looking at 1 inch. And now flute length, this is the actual length of the cutting tool. For the tool I have in front of me, I can use my calipers again to measure that, and I'm looking at 0.875. So that has gotten all our tool geometry information input. So from there, I can go to shaft. This doesn't matter for what we're doing, so we're going to just go to the holder information. Now from here, you can create a holder geometry, or if you have holders already set up, you can select them. I know I'm using a CT40 style holder. Let's see, CT40. Yeah, none of those are actually what I'll be using, but anyway. So there are just blank holders that are already programmed into the Fusion catalog. You can include those, but you don't have to put a holder if you don't want to. The holder is good for when you're doing especially 5-axis work where the holder might come in contact with your part. It'll let the program will throw up an error code showing that you're going to impact either your stock, or if you have a vise programmed in, your vise as well. So I recommend putting the holders in, but you don't always need them, or you don't need them to actually set up and run the program. You can extract holders, make your own holders, all that. I'll show you how to download the holder information from Haas later as well. Anyway, so I've got my tool set up. Cutting data, this is the second most important tab here. This is where we're going to set our information on how fast we are going to be running our end mill. So when programming in new end mills, we have our spindle speed, which is also a factor of our surface speed. Usually you'll find the information on surface speed in most product catalogs. And then cutting feed rate or feed per tooth, this will also be found from your vendor catalog. So where we will find that is we will go to the website that we bought our tools from. So right here I have pulled up Haas's website because I am using a Haas end mill. So I can go to Haas Tooling and end mills, and I'm going to filter to find the end mill I'm using. So I am using a 1/2-inch end mill, and which is for flutes. All right. So this is basically what I'm using. Oh, this one's got a chamfer on it, so I'm using a square end mill. Oh well, that'll do. So, I'm to find the cutting information. It'll be right here, speeds and feeds. So this is on the Haas website. Every cutting tool manufacturer has the information on their website, or at least all the ones I've looked at. Simply because the easier it is to find their information, usually the easier it's going to be, or more likely it'll be for you to buy their tooling. All right, so this is the information we need right here. So this is our feed per tooth and also our cutting speed in SFM. So we need to select the material we're using. So this is going to be made out of carbon steel. I'm going to be buying something like 1018 or A36 to make this out of, which is a very soft, mild steel. These codes are standardized, PMKSH. So this is steel, stainless steel, cast iron, high temp alloys, and hardened materials. So we will be in the P section here for plain old steel. And if you're not sure which, if it's 0 to 6, which one you're using, Haas was very kind to also give us this drop down where it kind of gives you an idea of what the tensile strength, hardness, and general material numbers for these different alloys are. So this would be A36 1018. So right here is what I'm going to be using. And that is a low carbon steel, which is long chipping, so P0. So I can come back up to this page here, and this first drop down right here is what I'm going to be looking at. So our CFM, our SFM, our velocity for cutting is going to be 490 to 660. So I'm going to pick a number within that range. Usually you can start at the lower end of that. And by starting at the lower end, you can always ramp up if your tool is doing well. So I'm going to go back to Fusion, and right here, SFM, I'm going to program in 490. So that has now set our spindle speed, 3,743 rotations per minute, because our axial speed for the rotation will be 490 feet per minute. So from there, I'm going to go back to Haas's information, and now I'm going to figure out how much feed per tooth I need. So I'm using a 1/2-inch end mill. So right here, it tells me to use 0.0034 thousandths of an inch. So that is 3.4 thousandths of an inch. It's kind of a weird way to look at it, or 0.0034 inches. If you've been machining a long time, you'd probably just say 3.4 thousandths of an inch. So right here in feed per tooth, I'm going to put in 0.0034, and that is going to update the rest of this information for how fast this cutter is going to move. If you don't have the information for your specific cutter, there's no real rule of thumb. Unfortunately, if you don't have the information provided by the vendor, it's going to come down to experience. And if you've worked this metal and this kind of cutter before, you can get a good baseline of what you should be running. And if you're new at this, there's not really anything good I can tell you except get some more experience. When you're starting out machining, it is a very difficult learning curve, and you are going to break a lot of tools. You're going to feel bad about it, but it comes with learning, so just try not to make the same mistakes twice. All right, so we have our spindle speed programmed in, our feed per tooth programmed in. Now we can hit accept, and right here is our 1/2 inch flat end mill. So I'm going to select that down here, and now that has auto-populated. I can see my end mill up in the air here, and it's got our surface speed, spindle speed, feed per tooth, all of that is now auto-populated. Once I've set this tool once, I can always go back and reselect this tool. It's not going to disappear. It is now in my tool library for use on any job I wish. So I'm going to go to my next tab. So this is tool orientation. For this process, that doesn't mean anything. So the geometry tab allows us to select what kind of geometry we're going to be machining. So where in this block are we machining? We can avoid certain areas down here, and we can also select boundaries of where we want to machine. Right now, I want to machine all the material I can off, except for avoiding the vise. I don't have a vise programmed in, so I can't select groups. Instead, what I'm going to do is go to the Heights tab. In the Heights tab, this shows us our clearance, our retract, and the top of the model. So from here, clearance height I'm going to leave at 0.6, retract height, so after it does any kind of cutting operations, it's going to come up to move over. That is going to stay the same. Feed top heights, that's going to stay the same. Model bottom is what I'm going to adjust. Because when I look at this, it's going to be in the vise, probably going to be holding on to at least a 1/2 inch. So what I'm going to do is from model bottom, I'm going to do negative 0.55. Nope, I'm going to do positive 0.55. All right, so at positive 0.55, what has that done is brought up our bottom from the bottom of the part up 5.5 inches. So that means if I set it a 1/2 inch into my vise and grab onto that, I will still have 50 thousandths over the top of my vise of clearance. So at that, my cutter should not intersect the top of my vise at all. I need to remember that that's how much I programmed in, because if I set it any deeper than 1/2 inch, so say I let it sit down a 3/4 of an inch into my vise, I will cut into my vise and wipe out my end mill. So that is important information to remember. So now in the passes tab, so here it's going to ask how much we are cutting, the tolerance for cutting, all that information. So generally tolerance, I'm going to leave at 4 thousandths because this is roughing operations. Sharp corners are okay right now because I want quick, not precise. Well, not that precise, I should say. So for optimal load can vary depending on the type of cutter you have. A good general rule of thumb is 1/3 of the diameter, which is 0.166 for a 1/2 inch, if I remember correctly. Whoops, accidentally hit enter, didn't want to do that yet. So I'm going to just right click, edit. All right, back to it. So optimal load 0.166. It all gives you an option to cut both ways. I do not recommend cutting both ways simply because most tools prefer to climb mill rather than conventional mill, and so if you have a good CNC machine, always let it climb mill when it can. Minimum cutting radius, not going to adjust that. I do want to machine any kind of cavities, and I want to keep it as climb milling direction. So for maximum roughing step down, it'll auto-populate with what it calculates based on the diameter of your end mill. You can leave it at that, and that's just a good rule of thumb. Same with the 1/3. So if you're comfortable with all that, you can leave it and just accept. Also right here, it has stock to leave. Since this is a roughing operation, I do want to leave stock on all surfaces so I can do a finish operation after it. So right now it auto-populates with 20 thousandths of radial and axial stock. If you're wondering which one's radial, which one's axial, just hover over it for a minute and it'll give you nice little pop-ups. If you're ever lost or not sure what something does, just hold, look at the pop-up. They're very helpful, and this is actually how I learned a lot of how to use Fusion. So if you don't want to just go with the regular what it auto-populates with, the manufacturer usually tells you what the cutting information is. So I'm going to go back to this cutting data. So we are side milling, so that's going to be A. And so it's going to tell us right here what our cutting information is. So AP and AE. So that will tell us how deep and how far in we can go. So this says we can go 1.5 times the diameter for depth of cut and half the diameter for cut width. So that means our step down can be 3/4 of an inch and our step over can be 1/4 of an inch if we're using a 1/2 inch, because 1.5 times 0.5 will give us 0.75, and 0.5 times diameter, which is 0.5, is going to give us 0.25. So that is where I would put our program here and here. But traditionally, I prefer the 1/3 rather than 1/2, and actually the 0.75 is a good step down. The reason I go shallower on my step over is because that reduces force on the cutting end mill, and I can actually move the machine a little bit faster, and that'll allow chip thinning, where we're actually cutting a thinner, longer chip, and it tends to be easier on the machine. So now I have my step downs, all that information in. I can hit OK, and it will start generating a adaptive toolpath for us. So this is the toolpath that it has created. Our blue lines are cut lines, so this is where it's actually going to be cutting. Our green lines are lead-ins and lead-outs, and our yellow lines are rapid movements. So if you're curious on what this looks like, we can go over to the simulate, and we can click that, and it will show our end mill. Once we hit play, it will show how our end mill is going to cut. If it feels like it's going too slow, we can drag the slider, speed it up. We can also slow it down. But this is a very helpful tool. You will spend a lot of time watching these simulations. A lot of time. Because this, especially if you program in the tool holder, it will show if you're making contact with any of this, any of the parts of your stock. And it will throw an error. It'll continue going, but it'll throw an error saying that you will make contact. And so that is a good way to figure out if you're going to crash your machine before you actually even get over to the machine. Because we don't want to crash anything. We don't want to break anything. Or at least we're trying our best. So exit simulation. Once we are here, we can start finishing operations if we want. And to do finishing operations, what we need now is basically to remove the rest of the material from all of these sides. So what we can do now is, for this outside length, I usually use a 2D contour. So I'm going to select 2D contour, and then I would select, so it's already auto-populated with my 1/2 inch end mill. And so here it's asking me to select a contour. So if I hold my cursor over any of these, it'll show these lines appearing. So that is the contour. It's asking me if I want to select. What I'm going to do is select this contour and this contour. So we can see this little red arrow appeared. that arrow shows us which side of the line that the end mill will be offset to. This is what we want. We want it on the, well, if I'm looking at it this way, the right-hand side, because if it was on the other side, it would cut into the stock itself, not cut off the excess. If it is on the wrong side, what you can do is right-click on what you've just selected and hit flip direction. And, well, yeah, I had the wrong one selected. Anyway, flip direction, and now the arrow's gone the opposite direction, so now it'll be inside. In fact, if I run it like that, it'll actually cut into my part itself, which is what we don't want. I can show you what that looks like in a second. In fact, I'll actually leave that. Flip direction, I'll show you what that looks like in the simulation. Now, right now, it's going to just follow this top line. That's going to do nothing for us because it's not going to be cutting anything. So for bottom height, it auto goes to selected contours for this. I'm going to do selection and then select this face right here. That now means it's going to face that or chase that same outline contour, but it's going to do it at the height of this face right here. Offset 0. And for this, I don't want to do it all in one cut because the cutting length of my flute is not enough. So what I'm going to do is come down here to multiple depths. In that drop down, I'm going to do a max roughing step down of 0.375. I'm doing lighter, smaller cuts now because that's going to be less tool pressure, which means I'm going to get a better finish. So 375, 0 finish step downs because this will be the finished step down. And from there I can bring this menu up, hit OK. And there we can see it's going to take 3 passes following that contour line. And if you remember, we flipped this over to the wrong side, and you can see how it has this like gray mass now. That's because the end mill is cutting on the inside, not the outside. So we don't want this. And in fact, in the simulation, if we try to run that, it's going to cut the outside. And you can see how it cut into our block. We don't want that. So exit simulation, right click, edit. Then I'm going to go back to geometry, select that chain that I wanted, and flip directions. Alright, so now that's going to go on the outside, that's going to go on the outside. Okay. There we go. Now both of our blocks are being cut. Obviously it's stopping right here, so if I want to go all the way down to the edge here, I'm going to have to do another 2D contour. So 2D contour again. Again, flat end mill comes up, half-inch end mill comes up. Now to select this contour, it's not going to let me just select it as a contour because the computer can't see it when it does that line. So what I'm going to do is in the geometry selection, I'm going to do a silhouette, and then in this drop-down tab here, I am going to select outer loops. So this has given me the silhouette of my part and just the outer loop. I can hit OK. And now height, obviously I don't want to go all the way down like I did last time. So what I'm going to do is selection, select the bottom of my model, and then 0.55 like I did last time. So this will be bottoming out at the same location as I did on the other one. Now for the first step downs, we've already in our previous cut from here to here. So now we just need to cut from here to here. So I am not going to worry about multiple depths. Let it drop all the way down. Hit OK. And there is our line. So now if we watch that one in our simulation, right here, simulate, it's going to do a nice even cut around the outside of our vise. Alright, and we can see we still have material left to come out in this setup, which is going to be on this top face and this top face, as well as the center of our vise. So I'm going to do exit our simulation, And now I'm going to do flat. So still staying with this 1/2 inch end mill. So we're not adjusting anything there. I'm not adjusting any of the height tabs because there's nothing past the vise. It's the only tops it can see is here, 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 and here. What I am going to do is stock to leave. Now I have already cut this face and this face. I know that. The computer can't always see it. So what I'm going to tell it to do is stay away from the radial, or to cut axial stock down to 0, but to leave 0.125 on the radial stock. That should leave these faces from being touched, I think. We'll find out. Anyway, for step over, we are going to again go with 0.166 for our step over, and okay. Let's see what it does. That looks right. So we're going to simulate it, see what it does. Come in through the center, cut out the material without touching that face. Remove material from the top there. All right. That looks good. So exit. Now I can select this whole setup, hit simulate, and it'll run everything together. So first is our roughing operation. We're going to rough out the majority of this material. Everything looks good. So the next one is going to be our 2D contour around the tops, 2D contour around the base, and now the flat cuts. So you can see that it changes color for each operation. That's so you can distinguish them. There is a limited number of colors, so after too many operations it starts reusing them. But no error codes were thrown up. Everything looks good. It doesn't look like it's going to hit. So that is all for the first setup in this operation. Now we're going to have to do at least 2 more setups to get this finished, but the video is running a bit long, so I'm going to exit simulation, and in the next video we're probably going to do the next 2 setups to get this operation finished. I am also going to show you how to import entire tool libraries from vendors and import holder libraries from vendors. So be ready for that if you want to see it. Hopefully this answers some of the questions that you may have and some of the questions that my students are having. And I hope you enjoyed the video.